Okay, so again, we're doing two things in the series. One is we're looking at confidence intervals. What is the range, 95% range, so to speak, that we would feel confident that the value falls within. So we like to be more precise, but we need to have a little bit of fudge factor. And the second idea is very closely related, is hypothesis test. So essentially, if a value um, lies outside of the confidence interval, then there's some disagreement there. So I've gone through a variety of some, I guess, motivation or theory. So here is really just a four-step process, and I'll do this for a couple ones, and then I have a summary table. So for a two-sided hypothesis, the the null is that it's equal to some value p0 or p null. The alternative, again, because it's two-sided, is, well, it's not equal. It could be higher or lower. The next step, and we do that usually before we've seen the data. It's someone's, maybe it's based on another data set or just a hunch. Secondly, then we want to actually process our raw data, do our survey, and we find the sample mean, proportion, or X bar, and the standard error. Third step, calculate the 95% confidence interval as if our claim was true. Okay? You could realistically flip it around and then see if the claim fell within the 95% confidence interval. In some way that may be a little bit quicker, but a little more formally, this is the way you're supposed to do it. So we calculate the 95% confidence interval around the claimed value, and as long as the evidence doesn't fall within this range here of, this is the sample average, and then plus 1.96 standard errors and minus 1.96 standard errors. The fourth step then is we check then with our sample average, p hat. Is it in this range? If so, all right, it's close enough. We do not reject our claim. If it's outside it, again, two-sided, it could be higher or lower, then we reject it. Similarly, for a one-sided hypothesis, and I've done two here. I know it's a little bit confusing, but that hasn't stopped me before. Anyway, here. So it's essentially the same four steps. The only difference is now there's only, if we claim that p is less than or equal to some value p0, then we get a little additional, this is kind of the fudge factor range right there. But if it goes much higher than our claim, then we've got to go with the alternative. Likewise, so this is just flipping things around. So mostly you can just follow this if you just want to do one case. But here's the flip side here. So now if our claim is that it's greater than equal to p0, then I didn't quite put the line right there. Never mind. Okay. Anyway, so anything, all right, all blue, fine. So if we claim it's greater than, whatever this is, 60%, we can actually go a little bit lower than that and still not reject our claim because, again, it's given us benefit of the doubt. But at some point, if we claim it's 60% and it's 45% or 2%, then we, at that point, the evidence overrides the claim. Okay. So this next page is a couple more examples, kind of scribbled out here, just putting some numbers on it. Some people don't like to think in terms of p0 or one more variable to think of, but look through these. This final page, in some sense, this is all you need here, and there's so this column here is for percentages or categories. So if we're trying to claim that the business major at Asbury is 20%, and then we could use this column here. And then there's the two main things we're interested in. Well, this is from the information from our sample or survey, so the sample mean or sample standard deviation, or if you have two groups, you have two means and two standard deviations. The standard error then is found from those. And then this is really our first one here, which is, oops, okay. Looks pretty simple here. 95% confidence interval is just the sample mean plus or minus 1.96 times the standard error. Then the rest of this from here on down are the hypothesis tests, whether they're two-sided, one side to the right or one side to the left. And this gives you kind of the generic version of that. So you can refer to this. I'll have this PDF on the discovery, and you can look through it. And it may not fit, and not all these will fit. You may not have proportions. You don't have to, you don't have to test everything. So if you're looking at, what impacts college or something, the idea usually with a survey is you have maybe one or two things that you're most interested in, or does studying improve grades? Right? Hopefully it does. Some people would claim to the contrary. So anyway, if you have questions about this, a couple things. One is, well, there's a few things. Number one, obviously just go through this here. This table I think is a good reference. Number two, there should be some Khan Academy ones, which are, I think, very good and would give you just some more examples, if nothing else. Certainly number three, contact me if you're just like, oh, this is all running together. I'm not sure how to use it for my data set. I'd be glad to give you some pointers there. And then the Shams, I may have already said this, but the Shams business statistics, hopefully you have that. It's a reference. You can look through, they'll go through this in a little more detail even. So, all right, there you go.